I'm here at New England District Championships, Richardson Division, checking out Team 2067 Apple Pie from Guilford, Connecticut. These guys are already having a great season. They were finalists at Greater Boston a couple weeks ago, and we all know that was a really intense finals match there. So we're going to be talking about a couple things, especially their intake, tons of 3D printed parts that are really cool to look at, and a pretty interesting climber and shooter combo setup. All right, let's jump in here. So first we're going to be talking about the intake, right?
Hi, I'm Radon. I work in CAD and mechanical. So our intake here is designed to pick up notes from all four sides. So the way we do this is we have all our wheels running this way, and this set of wheels running this way. So and we have Omni wheels on the side that helps pick up notes from the side. So the way it works is that when a note gets pushed in from the side, we drive over it, and then these wheels will pull them forward, and that'll allow it to put it into the shooter. And then same way from both sides.
So do you pick up on both sides crosswise, or you pick up front and back too?
Both, all four.
Very cool. You guys want to show us that quickly on the floor here? Wow, that looks rock solid, guys. I'm not surprised you guys are where you are at the quals right now. All right, what's next, guys? Show us what you got.
So I'm CJ, I'm the operator, and I do programming as well as electrical. And I'm gonna talk about the shooter. So we actually replaced our shooter for this competition. We were running Falcons at our last two, and for this we swapped to Krakens to really get the most out of our shooter, which we felt was most important. So we run 2 Krakens for our top and bottom rollers, as well as 1 Kraken under here for our feeder. And we also, so for these wheels, they are our shooter wheels. They make contact with the note and thrust it out. And these are 3D printed wheels that give us spin on the note. As well as this down here is our feeder, we call it. This helps with trap, amping, and intaking as well. So this bar here goes into the trap, holds it open, and we have this at an angle, so it just slides right in nicely. And these help us roll up and down the stage. So, yep. So as well as that, we have our elevator. So underneath, you might have noticed we have those hooks in place. That is also a hard stop for our shooter. That's how we get on the chain initially. And if you want to go up, we have these passive hooks that go down with our chain, and they latch onto the chain as we go up. They flick down, and then if you want to come down, they'll come back up. They'll hit the chain, and then we're engaged. And if we want to trap, you can go down again. They will just grab, and then we're able to raise the shooter. You want to do that, and then trap. Well, you don't really, yeah. Yep.
Very slick. And how successful have you guys been with that trap?
I think we've got it pretty much every qualification match. I think we've got it 10 times out of every match that we've trapped. So yeah, it's been pretty consistent.
All right, and then let's move on to one of the things I definitely want to cover with you guys, some of your 3D printed parts. You have a lot of custom 3D printed parts, and I think it's really cool to show.
All right, I'm Steven. I do CAD, mechanical, and outreach. And so we have everything you see here that is red is a 3D printed part on our robot. So you can see we have our 2 camera mounts, one up there, one back there, both custom designed camera mounts that allow us to visualize multiple APRO tags at any given time. We also have these wheels here, which CJ already covered, which give us the spin. The nice thing is that we could choose the exact amount of compression that we wanted here to adjust the spin. We also hold our sensor with a mount that allows us to adjust the location of the sensor so that we can change the delay in when the note is stopped in the shooter, and therefore get it to right before those shooter wheels. We have this wheel, which runs against the stage while we're climbing. We have our swerve guards, and then we also have a lot of TPU things. So if you can see here, those black things here, those are custom TPU rollers. They have quite a bit of squish to them, and those allow us to have the exact size we wanted with the exact amount of compression we wanted, and the nubs give us quite a bit of grip. And as well as that, we have TPU wheels underneath, which you cannot see, but we have an example here. So these are designed by 88. They are amazing. They have great traction on the field. It means that we don't have to worry about sliding across the carpet, which is a great benefit for our autos. We change them out after quals and then after playoffs at every competition, and they've worked great. And then we have one more pretty awesome 3D printed thing, which is going to be hard to see, but our swerve covers down here, the ones that guard our wheels. As the wheel turns, they go in the direction of the wheel turning, and means that we have the maximum area for the note to pass under our robot, while simultaneously like helping us not run over notes on the field. We have not run over a single note.
Very cool. Very cool. Yeah, there's so many cool applications of 3D printed parts I've seen on the spot. I mean, you talk about how 3D printing lets you get the right amount of compression. So were you taking advantage of how iterative you could be with that, and sort of like, hey, we printed these wheels up, and we printed ones that are slightly bigger and slightly bigger. We tested them all, and this is the one that worked?
Oh yeah, we've had an insane amount of modular design with this, because every part of our robot is designed to be modular. So we take all of these wheels, and this wheel, for example, has gone through so many iterations. We've gone through for the shooter wheel too, and pretty much everything. The camera mounts as well, the swerve covers, endless iterations of it. And even our intake, the fact that every single CNC'd part of it can be removed independently and replaced, has allowed us to change our belt distances and wheel sizes and lift it up and put it down as we needed more or less compression against the ground.
So hello, my name is Gordon, and I'm lead programmer, and I'm going to talk to you about some control stuff we have. So as Steven talked about, like, we have these 3D camera mounts, and right now we're running 2 cameras, and they just go into these orange pies here. And what we do is, like most teams, we fuse our vision pose estimates, which we get from the April tags, with our pose estimation from the odometry, which is like gyro and also our swerve modules. And in auto, that gives us like a really accurate estimate of like where our robot is at all times. And like we use that in combination with our shooter. Like, we have a piecewise linear fit. So based on the distance, we can find the angle that we need to raise our shooter to. And we have a zeroing sensor to make it like our shoulder really accurate. And we can also adjust our robot heading to face the speaker wherever we are.
Cool. What are you guys using for processing? Are you guys using photon vision, or?
Yeah, we're running photon vision just on our 2 co-processors, and yeah.
Very cool, guys. Well, hey, this is a really slick robot, and I hope you guys all the best tomorrow in eliminations, but I think you guys are going to kill it. So awesome job, guys.